Hello everybody and welcome to today's presentation, Serverless ETL with Cloud Functions, brought to you by Fivetran. I'd like to introduce our presenter, George Fraser. George Fraser is the CEO and co-founder of Fivetran and a fully managed data pipeline built for analysts. When Fivetran began in 2012, its founders realized that ETL tools were ill-equipped for modern companies that rely on cloud applications and databases. To meet the needs of analysts in today's new era, Fivetran built the only zero maintenance, zero configuration data pipeline on the market. Fivetran is now part of a growing cloud infrastructure ecosystem that gives organizations control of their data without heavy engineering. And with that, I'm going to turn things over to George to begin the presentation.
All right, thanks so much for that great introduction. I'm really glad to talk to everyone today. As said, my name is George. I'm CEO of Fivetran. I'm going to talk to you today about how to do data pipelines from custom data sources into your data warehouse with Fivetran and with Cloud Functions. But before I talk about Cloud Functions specifically, I want to talk just a little bit generally about what Fivetran does, what we've been doing for the last 5 years, and why we realized that we needed Cloud Functions as a way to support custom data sources. So Fivetran is a data pipeline. We synchronize data from companies' systems like Salesforce, like databases, like their support system into their data warehouse. And once it's in their data warehouse, they write SQL queries against it, and they typically run BI tools to build dashboards so that everyone in the company can have transparency into all of the company's data. Data pipelines are not a new category. Data pipelines have existed for years and years, but what we did really differently 5 years ago when we started was that we built an automated data pipeline. The approach we advocate for, we like to call ELT. The idea is that instead of building a very customized, very complicated, fragile data pipeline that transforms the data before it loads it into your data warehouse. This would be the classic extract, transform, load workflow. Instead of doing that, we're going to do an ELT workflow. We're going to synchronize all the data in its native form directly into your data warehouse. We're going to do basic cleanup operations, but we're not going to do heavy transformation of the data. And most importantly, we're not going to do anything that anticipates the particular analysis that we're planning to do later. We're going to load the data in a very analysis agnostic format. This is a great workflow for many reasons, but one of those reasons is that this whole front end side of the system can be managed by a vendor like Fivetran. Because the system is not configurable and is not anticipating any of the particular analysis you intend to do, we can just take this off your hands and do the entire extract and load portion of this process as a service. Just a little bit of details about our approach. We try to map the data from source to warehouse one-to-one. So that means when new data arrives in the source, we add that data to your data warehouse. When rows are updated in the source, we go and update those rows in your data warehouse. And when rows are deleted in the source, we don't actually delete them from your warehouse because often you don't want that. Instead, we set a special column, Fivetran deleted, to true. So we flag rows as deleted. We don't just do this for the data, we try to take the same approach to the metadata. So when the schema changes in the source, we map those schema changes to your data warehouse. And this is something that makes us really different than classic data pipelines. And it makes it radically easier to operate because this is the source of most of the pain and suffering of maintaining data pipelines. So this means if you add a column to your source, we're going to add a column to your warehouse. We'll actually go in and run DDL statements to add a column to your data warehouse. If you remove a column from the source, much like we won't actually delete data, we won't actually remove it from your warehouse. We'll leave it there in case it has some important historical data. And if you change the type of a column in the source, and this, by the way, is the hardest part, we will actually go in and migrate the type of that data in your data warehouse. And lastly, if you add a new object in your source, we will add a new table in your data warehouse. If you remove an object, again, we will just leave it there in your warehouse in case it contains historical operation information. So we've taken this automated approach to many data sources. This is a list of all of the data sources we supported as of a few weeks ago. The list is growing rapidly. So we're able to automatically sync all of these data sources into your data warehouse. And this includes several different categories. We can sync all the major databases. We can sync file stores like Amazon S3 or Google Cloud Storage, or even Dropbox. We sync applications. Some of our most popular ones are things like Salesforce, finance systems like Zora, support systems like Zendesk. We're able to take this automated approach and sync all of these data sources with very little effort from the customer. This has been a great business for us. It's been great for our customers. However, we recognized in the last year that there are cases where this is not sufficient. There are custom APIs, for example. There are APIs that were created by the customer, and we're never going to support a custom API. The whole premise of our business is that we build standardized data pipelines, and they're more reliable and better documented because they are standardized, and there's many people using them. Fivetran builds the perfect Salesforce connector once, and then everyone can benefit from it. But we're not going to go and build a connector to a custom API that only you have. Similarly, if it's just some incredibly obscure API that there's only a handful of companies in the world that will ever want to sync from, we're not going to be able to sync from that either. And this was a big challenge to us. Our whole business was premised on these standardized data pipelines, and it was really not immediately obvious for us how could we support these custom data sources, because they are important. And this year, we came up with what we believe is a really great way to support these custom data sources, and that's to use Google Cloud Functions and AWS Lambda and soon Azure Functions to allow Fivetran to work with a little bit of customer-provided code in order to support one of these custom data sources. So I'm going to show you some docs of Fivetran, some docs of an external service that we're going to integrate with. This is going to be kind of a live demo here. I'm going to show you some code and what that looks like. This right here is what the Fivetran dashboard looks like. If I jump over to Fivetran's production account, you can see, for example, we're syncing our Postgres database, we're syncing Salesforce, we have a list here of all of the objects that are in our Salesforce. We're not syncing everything to our data warehouse, just the things we need for reporting. And then I have over here a little demo account that I set up just for this demonstration, and I have a Lambda in here. So this is a Google Cloud function that I'm going to go through today that's currently syncing some data. So in our docs, there is an explanation of how our Cloud Functions implementation works and how you can use it to integrate with AWS Lambda or with Google Cloud Functions into a custom data source. And there's a little explanation here of some of the things I just talked about. What are the use cases where you would want to use a Cloud Function to sync data from a data source? It's when you have APIs where there is no connector, private APIs, strange file formats that require pre-processing. The basic strategy for Cloud Functions is similar to the way Fivetran syncs every other data source. So Fivetran needs some information to authenticate into the data source. We're going to start every sync by syncing the historical data from that data source, and then we're going to process that data. We're going to send the data from your custom data source to the same core data pipeline that we put all of the data from all of our sources through. And this is the big benefit of using Fivetran in conjunction with your own Lambda to connect to a custom data source. You're going to get all of our type inference code, all of our schema update code, all of our deduplication, all of our warehouse ingestion code. You're still going to benefit from all that, even though you're the one writing the actual update function that gets the data from the custom data source. And you'll see exactly how that plays out in an example today. And we're going to load that data into your data warehouse, and then we're going to go into update mode. So we're going to actually compute incremental updates from this data source, and the details of how that works, how you are able to write a function that can support incremental updates, I'm going to show you in just 1 second. So Fivetran's Cloud Functions connector is based on HTTP requests. Every time we make an HTTP request, that request is going to have a standard format. That request is going to look like this. It's going to be a JSON object, and it's going to have 2 entities in it. It has one entity called state and one entity called secrets. And each of these serves a different purpose. The purpose of secrets is to give you a place where you can store things that you don't want to check into your source code. These are things like API tokens that give access to an API, things like database passwords that allow you to log into a database. It's not a good practice to check in secrets like this to your source code, because then you can't change them, and anyone in your company can see them and they can potentially leak out. So we're going to give you, when you set up the function, a way to input these secrets into Fivetran. We're going to store them encrypted inside our database, and then we're going to pass them into your function every single time we call it, so that you don't have to check them into your source code. The other thing we're going to pass you with every request is this object called state. And this is the key to performing incremental updates. So state is things like a log position from a database, a timestamp of the last modified entity that you got from some API. Sometimes it's an ID, an integer ID that API uses for keeping track of paging. This can be anything that you want it to be. The first time we call your function, state is just going to be an empty object. But when you return on this function, you're going to pass back a new state, and we're going to remember that, and we're going to pass it back to you. And this is a very general mechanism that you can use to construct a incremental update function. So the response format that your function sends back is kind of a mirror image of this request format. So the response format, like I mentioned, is going to contain the new state. And what's going to happen is, if we succeed in ingesting the data in your warehouse, then we're going to remember this new state and pass it back to you the next time we call the function. If we don't succeed, we're going to discard the new state, and we're going to try again with the previous state to get the same data a second time. And this is a very important principle. This means that your function needs to be idempotent. It needs to be a pure function that does not track state internally, and it needs to be idempotent, which means we can call it multiple times and get the same result. The second thing that you're going to pass back in your response is the inserts. So these are all of the rows that you would like to ingest into your data warehouse, and they're going to be organized by table name. So in this example, there's a table called transaction with some rows in it, and there's a table called campaign with some rows in it. The rows of this object, of each table, can be any JSON object. You can have any fields you want, and Fivetran is going to look at this data and infer the number of columns, the names of the columns, and the types of the columns from the data we actually observe. This is the same core pipeline that powers all of Fivetran's automated connectors. This can do things like, if you pass data with a mix of types, like if in one row amount is an integer and then the next row amount is a date, we will infer as the least common supertype string. So you can really pass us back anything, and we will be able to turn that into a reasonable schema in your data warehouse. The third thing you're going to pass back in your response is delete. And this is optional. You don't have to pass this, but what this allows you to do is to mark rows for deletion before the inserts. So there are some scenarios, like for example, if you're syncing files from somewhere, if in order to make your function idempotent, you're going to want to do a delete on the name of the file before you insert the rows that you observe in the file. This is to deal with situations like if the number of rows in a file shrinks from one update to another. If you go from 100 rows to 50 rows, you want to delete the 100 rows before you insert the 50 new rows. The second to last thing that you're going to put into your response is the schema. So this is like the other responses, organized by table name. You do not have to give the entire schema of the table. You don't have to tell us the type of amount. You don't have to tell us what columns are available. All of that we're going to infer. The one thing that you have to tell us is the primary key. And we're going to use this primary key for two purposes. One, we're going to deduplicate the data that you give us. So if you happen to give us 2 rows with the same primary key, we will actually skip all but the last version. And this, you'll see, makes it a lot easier to write your functions. The fact that you know that the data is going to get deduplicated by Fivetran makes it a lot easier to write your update logic, because you can safely just iterate over collections and send whatever you find and not have to worry about, am I sending the same thing more than once? The other point that I should make about the schema object is, much like the delete object, it is optional. So you can leave out the schema. If you leave out the schema, we will simply keep track of every request and reply we've made, and we'll ingest all that data in append-only mode. The last key in the response that you're going to return is called has more. And what this says is that there are more items that are available from this data source, and you should call me back right away. So if you return a response that says has more equals true, then Fivetran is going to call back your function immediately for more data. If has more is false, or if has more is not present, then we're going to wait for a user configurable amount of time before the next update cycle. As I mentioned earlier, it's really important that you write your functions in an idempotent way. The fact that your function is idempotent works in conjunction with the way that state works to allow you to build reliable data pipelines. We're also going to create in your data warehouse a couple of system columns, Fivetran batch, which tells you how many times we've called this thing, and Fivetran index, which just tells you what was the position of this row within the response for this batch. All right, so let's do a demo. Let's sync some data using a cloud function. Today, I'm going to sync some tweets. Twitter's got a reasonable API, so let's say we want to get some tweets into our data warehouse, all right? And whose Twitter feed should we sync? Naturally, the most important person on Twitter, Justin Bieber. We're going to sync Justin Bieber's Twitter feed into our data warehouse. Justin Bieber has been tweeting for a long time. He's got a lot of followers, so we're gonna write a little API call that's going to grab his latest tweets and sync them into our data warehouse. So if we take a look here at the Twitter API docs, in order to sync data from Twitter, we need to do 2 steps. First, we need to get a token that will allow us to make requests to the regular API. So the way this works is that we have to register a Twitter app. We have to make a call to this OAuth2/token endpoint. This is called the application only auth flow. And we're going to send our consumer key and our consumer secret to this endpoint, OAuth2/token. And then it's going to give us back this response with an access token that we can use to make regular API calls. So once we have this access token, we're going to call this user timeline endpoint. So we're going to have an authorization header with the token we got from the previous API call. And then we're going to use the screen name to select Justin Bieber's Twitter feed. And we're going to use the since ID to create incremental updates. So this allows us to say, this isn't the first time I've called. I only want to get the tweets since this one. So I've made a little Twitter app here for the purposes of this demo. I've got a consumer key and a consumer secret. I just set this up the other day just for this demo today. I've got some code here that I wrote last night here in VS Code. So this is going to be my Fivetran custom Lambda connector, and this is going to be deployed on Google Cloud Functions today. We support both AWS Lambda and Google Cloud Functions. The demo I'm going to show you is going to be on Google Cloud Functions, but this code works almost without modification on AWS Lambda as well. So here is my function. This is the main method that's going to be called by Google Cloud Functions. It takes 2 parameters, a request, which is going to be the Fivetran request, and then this response is a callback that I'm going to use to send the response back to Fivetran. This is going to be hosted on Google Cloud Functions, but it's going to be called by Fivetran. So the first step here is that we're going to get an access token from Twitter. So we can do logs, and Google Cloud Functions, as you'll see in a minute, is going to keep track of these logs for us. We are going to start by making a post request to this OAuth2/token endpoint. And we're gonna get this this consumer key and this consumer secret from the secrets attribute of this request. You saw earlier that the Fivetran request format is going to have a secrets object in there that we can use to keep track of things like tokens. And so that's what's happening right here. We've got that secrets attribute, and we're going to get the consumer key and the consumer secret from that. We're going to do what the Twitter API wants us to do, which is to base64 encode them and send them in basic auth. And then Twitter is going to send us this reply. We're going to accumulate it into a single string like Node.js wants us to. And then we're going to call this, we're going to parse it as JSON and call this withAuth function. So this is going to be that authorization code from Twitter. And it's going to be in the access token attribute of the response from Twitter. So we're going to log a message saying, okay, we've managed to get an access token. And now we're going to call the regular Twitter API. So we're going to call user timeline.json with screen name Justin Bieber. And this is really important. This is the incremental part. If that request state has a since ID attribute, this is that state object that Fivetran passes to us, and we get to pass back, and Fivetran will remember for us. If this since ID is not null, then we're going to add it onto our request. We're going to say, okay, Twitter, I only want the tweets since this ID, because this is not my first API call, and I want to be incremental. So we're gonna take that request path. We're gonna make a GET request. We're gonna use that access token we calculated in the previous step, and then we're gonna get this response callback. Once again, we're gonna accumulate all the data into a string, and when it's all finished, we're gonna call this with tweets next step. We're gonna parse that reply from Twitter, and we're gonna call with tweets. So Twitter's response. This is a response with just, oh no, wait, that's the Fivetran example. So Twitter's response is a pretty complicated nested JSON object. We don't want to just ingest that directly into our data warehouse. It would be really kind of messy, and it would contain a lot of deduplicated information, a lot of duplicate information. We want to normalize that data before we put it into our data warehouse. So we're going to do that right here. We're gonna look at the IDs of the tweets that we get back from Twitter to keep track of since ID, so that the next time we can be incremental. And we're gonna put all of our rows of cleaned up data into these tweets, into this tweets array and this users array. So that's what happens right here. Timeline is the response from Twitter. It's an array of objects, and we're gonna just go through all the tweets. We're gonna say they're in reverse chronological order. So for the very first tweet we encounter, we're going to actually remember that since ID. And then we're going to grab the tweet ID, we're going to grab the user ID from the nested user object, and we're going to grab the text of the tweet. And we're going to put that into a JSON object, and we're going to push it onto the tweets array. We're going to do something similar with the user ID. So there's this nested user object. We're going to grab the user ID, we're going to grab the user name, and we're going to grab the user screen name, and we're going to put that onto the users array. Now, we're only getting Justin Bieber's Twitter feed, so the only user is always going to be Justin Bieber. But this is an important point. We're not going to worry about that. This is kind of a silly example. It would be pretty easy in this case to deduplicate and to only send Justin Bieber's information once. But imagine if we were pulling many people's Twitter feeds, then it would get sort of complicated to figure out, have I seen this user ID yet? Or is this the first time I'm seeing that user ID? The point is, we don't have to worry about this. We're going to set ID to be our primary key, and Fivetran is going to take care of deduplication for us. So we're just going to take the user from every tweet, even though it's always Justin Bieber, and we're just going to push it onto this user array. Then we're going to send this JSON response back to Fivetran. So we're going to send a JSON reply, and this is going to be our response object. So we have a state with a new value of since ID, so that the next time we get called, we'll compute an incremental update. We're going to have a schema. We're going to say that the primary key of tweets is going to be ID, and we're going to say the primary key of users is going to be also ID. It's a different ID. It's the user ID. You can see that right here. We pulled this out of the user. We're going to put that, we're going to set that as the primary key, and that means Fivetran is going to deduplicate that for us. That means Fivetran is going to deduplicate these arrays. It also means if any of these tweets or users are already in our data warehouse, Fivetran is going to recognize that. Fivetran is going to do a merge operation to put this data into our data warehouse, so that even if we accidentally send the same tweet twice or the same user twice, we won't end up with multiple copies in our data warehouse. So I'm going to put the tweets and users as my two tables in the insert, and I'm not going to bother doing a delete. Fivetran is going to use a merge operation, like I said, so there's no need to do a delete here. You only really need a delete when something unusual is going on. I'm going to set has more to false. We're just going to collect one page on the initial sync. If we really wanted to sync Justin Bieber's whole history, we would have to make this a little more complicated. We would have to actually page backwards in time through his whole history on that first sync, and we'd use the has more to do that. But for the sake of keeping this example simple, I'm just going to sync the most recent page on the initial sync, and then we'll go into incremental mode. So this is my code. This is a complete connector that connects Justin Bieber's Twitter feed into my data warehouse. And I'm going to run this in Google Cloud Functions. This is the Google Cloud Functions interface. You can see in this little demo account I set up for this demonstration, I have just one Google Cloud function in here, Twitter demo. This is where the source of it lives. Deploying these things is really simple. You just push this edit button and you get a little window here, and you can copy paste your code right into it. You can also connect Google Cloud Functions to GitHub so that you can store your functions under version control. If your functions get complicated and you have a lot of them, this is a good idea. But for the sake of a simple demo, the easiest thing is just to copy paste it into this little box and say to deploy it. Google Cloud Functions isn't just deployment. It has a lot of other great features. So it has a great testing feature. We can use this to run tests of our function. So if I grab a little test request right here, I can actually call this function right from this interface. And you can see right here, here's our response. So I'm just going to copy this back over to VS Code so that we can format it. So this is what scroll back over to the left here. This is what the reply from Fivetran looks like. So you saw we just wrote that function. Here's what the function actually did. It found a new since ID for us. This is Justin Bieber's most recent tweet. It gave us that same schema we had before. And here's all the tweets. Now, Fivetran hasn't really done anything yet here, right? This is just the Google Cloud function that we wrote. This is what the response of it looks like. Here's a whole bunch of tweets. And then here's Justin Bieber over and over. Like I said earlier, we're not going to worry about sending duplicate data. We're just going to let Fivetran handle deduplicating the data for us. It would be easy to duplicate the data in this case because we know there's only one user. But in the more general case where we're iterating over many API endpoints, it can be quite difficult to keep track of duplicates, and it's much easier to just let Fivetran handle that for us. And of course, has more is false. So we can see how this state works even without using Fivetran. If I grab this state right here and I copy it into my test request, right? So now the secrets are the same, but I put in a since ID in the state, and I test the function again. You'll see I get a much shorter response. This time I get only one tweet. This is a duplicate, right? The way the Twitter API works, when you say since ID, it includes that ID. And that means there's always going to be a one tweet overlap between every request. But again, that's fine. Fivetran is going to use the primary key ID to deduplicate the data. when it merges into the data warehouse. And that means we don't have to worry about this stuff. That's why primary key is so useful. It makes it a lot easier to write your functions. You can be a little bit fuzzy about these things, and it'll all get worked out before it goes into your data warehouse. So we've deployed this to Google Cloud Functions. We've verified that everything is working. Now we're going to use Fivetran to call this function and ingest the resulting data into our warehouse. So that's right here. In my little demo account here, I have just one connection, our Google Cloud function. When I set this up, I used this screen to do it. So this is what it looks like setting up a Google Cloud function in Fivetran. You put in the HTTP URL of this function. So that we got from, right, where is it? Right here. Here's our HTTP endpoint. I put that into the function trigger, and then I put my secrets right here. So these are the things that Fivetran is going to keep track for us, our consumer key and our consumer secret. It's going to call, it's going to include this with every single request. And when you write this, we have this nice test function. So when you click save and test, it goes and it verifies that that cloud function actually exists, that you didn't make a typo when you transferred it over. Then Fivetran runs this function automatically. So you say, how often do I want Fivetran to call this function? I've said every 1 hour. If the function fails, how long does it have to fail for before Fivetran will start sending me emails and telling me, hey, something's wrong? And I've set that here to 6 hours. Importantly, we can actually resync all historical data here. So we've set all this up. I set this up last night. And it's run a bunch of times overnight. And I set it up to connect to a Snowflake data warehouse. So right here, I've got a Snowflake test data warehouse that I've configured this account to send data to. Setting that up was similar. It's just basically a form where you enter a bunch of information. You say, where's the Snowflake account? What's the user and password to use? And what database do you want me to use to put all this data into? And I've got that open right here. So here's my Snowflake data warehouse. And if I do a real quick show tables, you can see there is a tweets table, there is a users table, and there's a Fivetran audit table. This contains information about how many batches we've run. And if I say select star from tweets, we can see here are Justin Bieber's tweets. So he said something most recently about some March. You can see they've all been deduplicated on the primary key. If I say select star from users, there's only one row. So even though we sent the same user over and over again, it all got deduplicated by Fivetran. So we've got all our data in our data warehouse. Cloud Functions have another cool feature which is relevant, which is that they have logs. So if we check out the logs here, they don't log the requests and replies, so our secrets are safe. But you can see all those console.log messages that I put in here are here. You can see each execution of the function here. You can see when I just called it a minute ago, when I ran it in test mode, here's the initial sync, which has 20 tweets. Here's the incremental update, which has 1 tweet. So these logs are super helpful for troubleshooting if anything goes wrong. So that's Google Cloud Functions from soup to nuts. You can do the same thing with AWS Lambda. So the code is almost the same. The AWS Lambda handler format is just a little bit different. The callback function is slightly different. We have examples here in our docs that explain these slight differences, but you could copy paste this function that I wrote almost exactly to AWS Lambda, and it would work the same way. And AWS Lambda has a similar deployment and editing and logging model as Google Cloud Functions does. So they both work great for this purpose. You should just use whichever system you're more comfortable with, and we will call it in the exact same way. So this example that I did today is a little silly. You probably don't want to get Justin Bieber's Twitter feed into your data warehouse. But there are innumerable real examples that you can do. Private APIs, obscure APIs, where you can write a simple cloud function that knows how to get the data from your source, and you can still benefit from the deduplication that Fivetran provides, from the type inference and the warehouse ingest, and most importantly, that schema update rules in your data warehouse. I like to say that even with cloud functions, you still get about 50% of the benefit of Fivetran's fully automated approach. We've really done our best to crush down the amount of code that you have to write to make things as simple as possible for you and have a clean handoff where we handle the fiddly warehouse and deduplication parts, and you can just write the minimal logic that knows how to update from that data source. I hope that's been a fun example, and I hope that it's been good for illustrating all of the features of our tool. And with that, I'd love to take questions.
All right. So our first question we have is, can I use other programming languages other than JavaScript?
Yes. So I did JavaScript today because it's a programming language a lot of people know, and because it's available in both AWS Lambda and Google Cloud Functions. In Google Cloud Functions, JavaScript is the only option. That's not because of Fivetran, that's just how Google Cloud Functions works. They only support Node.js as a programming model. They probably will add new languages this year, I suspect. In AWS Lambda, they have a lot of programming languages, and we have sample functions here for several programming languages. So we have Go, we have Java, we have Node.js and Python, and AWS Lambda also supports .NET and several others, and you can use any programming language that is supported by AWS Lambda.
Great. Our next question is, what if I send my data to 2 different warehouses?
Yeah, so if you have multiple data warehouses, or if you have like a data warehouse and a relational database and you want to send it to both, you can totally do that. The key here is to use that state object and write an idempotent function. So if you have 2 different data warehouses, if you set up your function correctly, you can simply set up 2 Fivetran projects and call the same function from both places. That does mean you'll call the same function multiple times, but as long as you use that state object correctly, they'll both be keeping track of states separately, and they'll both end up with the same data sets.
Awesome. Our third question is, what would happen if I have new columns in my data source?
Yeah, so I talked about that a little bit in the slide. So these rules that we use for every data source apply to lambdas as well. So if you add a column to the data source, we'll add a column to the warehouse. And if you change a type in the data source, we'll change that type in the data warehouse. It's a little bit subtle what that means in the context of lambdas. So in the case of lambdas, we're always going to be inferring that schema from the data you send us, right? So if we look at this example of the Twitter response, we're going to look at these attributes and we're going to infer types. So we're going to infer an integer for ID and user ID, and then we're going to infer a string for the text of the tweet. And if you send us data over time that contains a mix of types, we will figure out what type will contain all of the types you send us. So if you send us a mix of integers and strings on the same column, we will infer a string. What this means in terms of new columns and type changes is that if one day you change your code or the source changes somehow and suddenly there's just like more attributes in this JSON object, we're going to notice that. We're going to realize that there is a new column, and we're going to go and infer a type for that column and add it to your data warehouse. So the automatic inference rules work in conjunction with our data warehouse update code to just keep everything in sync. It's a little bit of a maze behind the scenes, but the user experience is that it's very simple. You just send us whatever you want, and we will find a way to ingest that into your data warehouse. Are there any other questions?
Sorry. Our next question is, how do we measure API performance and troubleshoot performance issues?
So sometimes APIs have limits, like they can only, you can only make so many calls in a given amount of time. And in that case, you may have to add a little bit of logic to your code to check how many API calls you have remaining and make sure you don't overuse them. Sometimes APIs are just slow, and maybe that is really more the question. Like, what happens if, this is taking longer than I expect? How do I troubleshoot what's going on? And in that case, console.log is your friend. So you can use just regular old logging in these functions. This is one of the great features of these serverless computing platforms. You can log information about what the heck is going on, like you see I am here saying how many tweets I'm getting. And then you can see that information over here in the logs. And that includes timing, right? So we can see, the whole function execution took 518 milliseconds, and you can see how long each step took by taking a look at these logs.
Awesome. Our next question is, how would error handling, let me pick a different one. I'm so sorry. How to connect to an on-premise database through firewall via Fivetran.
So if your data source is a database, you will probably want to use a regular Fivetran connector rather than an AWS Lambda. Databases are one of the sources that we support. We support all of the major databases except SAP. And we have several ways of connecting through firewalls. So you can whitelist our IP. You can use an SSH tunnel if you really need to. So generally, I would recommend to someone, if they want to connect to a database, then you should probably just use regular Fivetran to do that. If you have, some really weird database, like maybe you have a database you invented yourself, first of all, I might suggest that you rethink that. But if you do have some really crazy situation like that, then you could use Lambda to do that. If that database is on-prem, then you're not going to be able to use Google Cloud Functions or AWS Lambda, obviously. But you can use any HTTP server. So Fivetran Cloud Functions are not actually specifically tied to any particular Cloud Functions implementation. It's really just an HTTP request protocol, which is described right here, the request format and the response format. So any HTTP server that follows this format is compatible with Fivetran Cloud Functions. So you could just set up a little Node server or Java server or whatever you're comfortable with, whatever matches the rest of your system. You could just set up a little HTTP request processor that follows this format, and we can call it and ingest your data. Now, if you build it yourself, you're not going to get all these nice features that are built into these platforms, like logging, like that nice little editing API that I just showed you. None of those are going to be there. That's, of course, the downside of not being on the cloud platform. But from a Fivetran perspective, any HTTP server that follows this protocol is a perfectly acceptable data source.
Next question is, what if my data source is a database instead of an API?
So similar to what I just said, if your data source is a database, I would recommend that you just use one of Fivetran's regular database connectors, and not write your own Lambda unless there's some really unusual circumstance that means you have to write a Lambda. There was a question that you started to ask a minute ago, which I think about error handling, and error handling is a really important topic. So I just want to say a quick word about that. So obviously things can go wrong. There's really two kinds of errors. There's transient errors and things that are truly broken. So when things are truly broken, that might be that your credentials have been revoked, or maybe your code is broken, or maybe the API that you're pulling from has been changed and your requests are no longer allowed. They made a breaking change. APIs shouldn't do that, but sometimes they do. In these circumstances, the connector is going to break. Fivetran is not going to do anything crazy. We're not going to go and ingest crazy data into your warehouse. You will see on your Fivetran dashboard that it is broken. When you go here, this will not be green scheduled. It will be red broken. And you will see logging information in these logs about what happened. So for things that are truly broken, logging is your friend. That's how you're going to figure out what's going on and troubleshoot it. For things that are transient errors, Fivetran is going to retry. So this will still show as broken temporarily. Once you pass this delay notification time, we'll start sending you notifications that things are wrong, but we'll keep retrying. And that's a key element of how this state concept works. We're only going to remember the state change when we actually succeed. So if the call to the source API fails, then we're probably not even going to get a new state. So we're just going to keep retrying with the same state. But if the ingest into the data warehouse fails, we also won't update the state. So if your data warehouse goes down, or if you revoke our permissions, or whatever reason our ingest into the data warehouse fails, we will retry several times. But if all the retries fail, we will give up and we will not advance the state. So then the next time we call back that function, it will be with the previous state. And that is the key idea of idempotence, is that we use the state in conjunction with an idempotent function to make this thing robust to errors.
Awesome. Would Lambda functions scale automatically based on data volume trends?
So Lambda and Google Cloud Functions are fully managed services, and they will auto scale. Fivetran is going to call them serially, so they're generally not going to auto scale very far. You will find that it is surprising how much data you can pump through one serial process. We have connectors that sync terabytes of data each month through a serial process. If you just write efficient code and you don't do crazy things, you can really get a ton of data through there. So Lambda and Google Cloud Functions are auto-scaling, but the protocol we have described is inherently serial. If you have really big data sets, you're probably going to end up using something like RS3 connector or a Google Cloud Storage to ingest that data. There is definitely some limit where using Lambda stops making sense if your data sets get too large. It makes more sense to actually write files somewhere and sync those files, but it will scale pretty far.
Next question is there going to be Azure support?
Yes, that is the next one that we are doing. It's a good question. We did AWS Lambda first. We did Google Cloud Functions second, but Azure is coming up. We know lots of people have it, and we want to support it. And we support Azure SQL Data Warehouse as a destination. So definitely, we need to support Azure Functions as well. You could, in fact, do it today just by leveraging the HTTP protocol, but we will. There's some authentication details and stuff that we need to do differently to make it easy. And we are working on that. Stay tuned.
Would XML also work as a data type?
Yep, you can really ingest any data source. The protocol that we follow is JSON, but you can write whatever you want in this function. So if we look at my function here, I'm processing the tweets from Twitter. This could be XML, and we could use a Node.js XML parsing library to parse that XML and turn it into rows that are ready to go into the data warehouse. So it's really up to you. The data could be in absolutely any format. It could be XML, it could be protobufs. That's actually a really good use case for this. If you have a data format like protobufs that is not self-describing, there's no way for Fivetran to automatically ingest that because we don't know the schema, but you can write a Lambda that knows the schema and ingest a format like protobuf or XML. So it's just up to you. It's basically you can write whatever you want in here and ingest any data format, your own data format, and as long as it turns into this JSON at the end that you send back to Fivetran, we'll be able to ingest it into your data warehouse.
And this question I'm about to ask looks like our last one that we have right now. What if my data gets messed up in my data warehouse? Can I start over and resend all of my data from scratch?
Yeah, so there is a button in our UI for doing that. So we go over here and we look at this. There is a resync all historical data thing. If you click this, it will ask you if you really, really want to do that. If I were to say yes right now, then what happens is that state object gets erased back to an empty object. We call back the function with an empty state, and the whole thing just starts over again. So that means your function needs to be written in a way that I know I sound like a broken record, but it needs to be idempotent. You need to write your function so that given the same input, it will always return the same output, and then it will work in conjunction with that state to resync all the data from scratch.
Is there anything else you would like to add, George, before I wrap things up?
No, it's been really fun talking about this today. Serverless is really cool. Serverless is a really great way to build ETL pipelines where you have to do something custom, but you can still have Fivetran do a lot of the heavy lifting on the other side for you. We're just really excited to see what kinds of things people come up with.
Great, and with that, I'd like to thank you, George, for a great presentation today. I'd also like to thank today's sponsor, Fivetran, for providing the DZone audience with a great webinar presentation. And lastly, thank you to everyone who showed up to today's presentation. We hope you learned something new today that will help you in your developer career. Have a great day, and we'll see you next time.
Thanks very much.